Hey everyone, welcome to the talk on GitHub-First Jupyter, how Pinterest solved notebook collaboration at scale. My name is Nikhil, and this is my first time at JupyterCon. Glad to be here. And sad news is that my colleague is not able to join today due to a conflict. We are from the ML platform team at Pinterest, and yeah, let's get started. Quick dive into the notebooks ecosystem that we currently have at Pinterest today. Uh, First one is Notebooks IDE, an interactive environment for notebooks development. We use Jupyter Lab hosted on Kubernetes for this today. Reports, nothing but executable Jupyter notebooks, which can be parameterized, run as a job, run as a workflows, persist notebook outputs, so that we can refer back to them at a later point. And some data access libraries for S3, Presto, Spark SQL, etc. Versioning of the notebooks often require creation of multiple copies of the same notebook. As you can see, that's the same notebook, but multiple versions created in fear of losing the prior work. And similar to that, this is the Jupyter Reports tool, which was also basically like for each version of the notebook, a new report had to be created. The first iteration of this tool was in 2016. It was a decently successful system, but the pain points were there was lack of version control and lack of access control, which would mean that anyone at the company is able to access these reports, whereas some reports might also contain sensitive information, which not all at the company should get access to. And the second iteration, this second iteration of the reports tool, we focused mainly on fine-grained access control so that these reports are only viewed by colleagues with which these reports are shared to. We've launched a new UI for reports and versioning. We've developed our own version control and code review systems, which we shouldn't have done. The pain points were UI was very unintuitive to use and very difficult. There was also slowness in IDE because behind the scenes we used, okay, there was some Slack notification. Behind the scenes, we used S3, and it was a little bit slow when compared to EFS. The system was tightly coupled and made iterating non-trivial. Migration faced user pushback, and it was paused. So we decided to go with GitHub for version control because we didn't want to reinvent the version control, the solution for version control, because GitHub already solved this well-defined problem. GitHub also enables code reviews, supports continuous integration pipelines via GitHub Actions and build kite. It also improves searchability through the notebook code via source graph and glean. And we also wanted to think beyond Jupyter Lab. We also wanted to support notebooks development in VS Code, Cursor, Windsurf, etc. We wanted to make sure GitHub acts as the interface between IDEs and reports. We also wanted to make sure that notebooks are treated as code, and we wanted to enforce strict coding standards like linting and formatting. When integrating GitHub, we faced a few key challenges. The first one is notebooks can contain PII or sensitive information. As you all know, notebooks can contain queries, and oftentimes at Pinterest, queries involves querying against some user's personal data. We wanted to first evaluate how much sensitive information is there in the notebooks present at Pinterest. And we've tried these libraries to evaluate all the notebooks that were available, and we got to know that roughly 4% of the notebooks were detected positive with sensitive information. So we wanted to make sure no information gets leaked to GitHub, because once the information is leaked, it's a non-trivial effort for the to remove the sensitive information from GitHub, and even though if it is removed, it always remains in the Git history. So we implemented a custom command called git-safe-push. This acts just like git push, But behind the scenes, it also adds an additional step of running a PII detector through the notebook code before making a commit to GitHub. And we also wanted to make sure that we have good enough migration tools. This is often overlooked, but is a very good amount of work that we have done to make sure we have easy to use tools to migrate the notebooks and reports from the legacy systems to the new system, and thereby introducing GitHub-based unified notebooks ecosystem. There you can see the Jupyter lab, which is hosted on Kubernetes, which uses personal EFS. Personal EFS means every user has their own workspace where they can create notebooks or clone their repositories. We also support AI-assisted IDEs like Cursor, Windsurf, and VS Code. And when users make changes, they are run through the PI detector. We use Microsoft Presidio today before we commit the changes to GitHub. And then using the reports tool, they are able to create reports from the notebooks residing on GitHub and trigger them ad hocly or schedule them, etc. This is how Git extension, Jupyter Lab Git extension looks like on Jupyter, where users can clone repositories. So user launches a Jupyter server with GitHub enabled, clones the repository, commits their changes, but before pushing their changes to GitHub, we also detect for PII secrets. And this is how our reports tool looks like now. The key features of this reports tool is to directly link your version controlled notebook, define inputs like dates, regions to run reports dynamically, tie reports to a specific notebook commits, and share your reports with colleagues easily. By default, it's only private, but you can share these reports with colleagues as you like, and schedule your report to run periodically. This is how versioning looks like now. Previously, there was one report for each version of the notebook, but now the report is tied to a specific notebook, and you can easily roll back or roll forward the version, and the report ties to a specific notebook version at a single point. This is how users can also schedule their report hourly, daily, weekly, and so on. And yeah, the pros of using GitHub is that we now support developing notebooks using AI-assisted IDEs by launching Jupyter server locally. And one other benefit is we can search through the notebook code using source graph so that other colleagues can get some examples of how to do various tasks. And this is one example of the detection that was caught before the changes were pushed to GitHub. In this case, there was a JWT token that was being pushed to GitHub and was stopped. Yeah, and for easily migrating the notebooks from non-GitHub to GitHub-based Jupyter, we have implemented a command so that within a single command, it will migrate the notebooks from one system to another. And for reports, we have implemented something called an import feature, and within a few button clicks, the reports are migrated from the legacy reports to the GitHub-based unified reports. This is how migration looks like. The user starts, adds params and configs, attempts push to GitHub. It runs through PI detector. If it triggers a review, the changes are reviewed manually. If yes, it continues. If no changes are detected, the changes are pushed to GitHub, and the report is created, and that's it. The key takeaways is GitHub really helped us in collaborating amongst the teams for notebook development, but we also made sure to have proper governance in place. so that sensitive information is not leaked. As you can see from the hockey stick curve, users liked it. There was a good adoption, and that's it.